All right, so for those of you on the recording, this is the monthly JavaScript Boulder meetup. And I would just like to introduce our speaker, Sharon. Sharon is a senior software engineer with 19 years of experience working on commercial enterprise software. She began working at Workday 3 years ago and has since enjoyed the switch to web technology. She leads a small web team in building a complex collaborative web app, and she is still learning new things on the job every day. Wow, what a great bio. And you're laughing. And thanks so much for volunteering to speak. Sharon is a coworker of mine at Workday, and we're super excited to have you.
All right, good. Hopefully that was pretty quick. Can you guys all hear me and see my screen?
Yep.
Awesome. Good stuff. Sorry about that. Thank you for the intro. Yeah, and this is my talk about Redux custom middleware and how it's so simple. You can actually go ahead and write it yourself. So first, to tell you a little bit about myself, but thank you for the great intro. I just want to mention that I do really love working at Workday. Super fun place to work. We have a lot of creative freedom on the development side. And I love the tech stack that we're working on, very modern, working with TypeScript, which is a savior for me. React with hooks, which has been a learning experience, and Emotion for CSS, which has been fantastic. It's been a great move for us. A little bit more about myself. I am a working mother, so I work full-time, and my husband works full-time as well. Luckily, we share all the household, child-rearing duties equally, but I can't emphasize how hard the pandemic has been for working parents. We are always struggling to find childcare, and school is on or it's off or it's hybrid and it's Zoom and partly in person, and we're worried it'll get canceled altogether. It's been a rough ride. And my director did post this graphic in one of our Slack channels, and it really resonates with me. All right, so moving along, today we're going to discuss what is middleware, off-the-shelf middleware, how to implement middleware, some action processing patterns, layered architecture using custom middleware, and we'll walk through a collaborative web app example. So first, a little refresher of basic Redux. So this is a really simplified diagram, but what I want to show here is that Redux begins with an action object, and it's just a JSON object. So I have it in this oval. And that object is passed to Redux's dispatch function. And the function then passes that action object on to the next function, which is the reducer or combined reducers. And the reducers process the action to create a new version of Redux state. And Redux state itself is really just another JSON object that we see here at the end. So what is middleware? Well, middleware is actually just a function. The Redux framework provides an extension point where we can inject middleware function into this chain of functions. This chain begins with dispatch and it ends with the reducer. This chain of functions is often called a pipeline, and you can think of it as a pipeline through which the action flows. So middleware actually has the opportunity to execute logic in response to an action after the action's been dispatched and before or after the action is processed by the reducer. And we'll explore how this works in the coming slides. So why use middleware? Well, React components should be focused on presentation logic. Reducers should be pure functions focused on managing state. Actions are simply messages with data. Where should we put our application logic? How can we perform side effects? Where should we make asynchronous API calls? Well, middleware is a flexible way to achieve all of the above. So you guys are probably familiar with some popular off-the-shelf middleware. Redux Logger is a fantastic one. I highly recommend it. And all it does is console log the actions that flow through the pipeline, but super handy for debugging. Redux-thunk is another popular middleware that's used for side effects. So it executes actions that are sent as functions instead of objects. And really, there are hundreds and hundreds of options out there. This is a link to Mark Erickson's blog, and he's got a very extensive list of a lot of creative middleware options out on NPM. So I kind of consider this group of off-the-shelf middleware, I call it customizable middleware. But in reality, it's really easy to write your own custom middleware. So we will move on into that scene. So it's time to look at some code. Let me find my mouse here. Here we go. So how you inject middleware into the Redux pipeline is that from the Redux library, you can import a function called apply middleware. And you can take this function and send it as a parameter to your create store function, which creates your Redux store. And the apply middleware function takes a list of middleware functions. And the order of this list is the order that the middleware is executed in that pipeline. And as you can see, it's really common to create middleware using a creator function. And we'll look at this in more detail soon. So here is a bare bones, really simple example, the simplest custom middleware you can write. So as we look at it, we see that the create custom middleware is a function that returns a function, that returns a function, that returns a function. And if we break it down, the creator function returns a function that takes the store API as its parameter. And the store API is just dispatch and get state from Redux. And this returns a function that takes next as its parameter. And next is simply the next function in the pipeline that should be called. So that is either the next middleware in the pipeline, or if you're at the end, then the reducer, combined reducer itself. So this returns a function that takes the action object. And finally, this returns a function which is the body of this middleware. And so we can see here, there's no logic in this body. All this middleware does is participate in the pipeline. It gives the action object onto the next function. And we work in TypeScript and Workday, as I said, highly, highly recommended. It's absolutely fantastic to have a compiler on your side helping you out. So here's what the function signature looks like with all its glorious types. All right, so middleware is actually really easy to unit test, surprisingly. Here's a quick example of a just unit test. And so we are going to create some mock functions, just mock functions. Here's the first one where we'll create a just mock function to represent dispatch and a mock function to represent get state from the store API. And we can see in jest, not only can we create a mock function, but the mock function can return a value too. So here it is returning app state, which is just mocked further up above. Then we create a mock function to represent the next function. And then finally, we can go ahead and just create our action, create our middleware. You can see I'm creating the middleware from the previous example. And then we can go ahead and execute our middleware. So we simply call it with the store API and next and action. And now we can run our just expect statements. So remembering the implementation from the slide before, we can expect next to be called with action, and we can expect the store API dispatch not to be called at all. All right, so here's an example of custom middleware that takes a configuration parameter in the initial function right here. So this way we can configure or customize the middleware at its creation time. So this middleware is just a little less bare bones. It's also, this one is actually going to console log the action and monitor the actions before sending it down the pipeline. And the configuration parameter we have is just a Boolean that says if we should console log this using console warn or as console log. And this is a contrived example that demonstrates what I wanted to. All right, so let's look at a more complex example. So the first thing this middleware does is use the get state from the store API to get the current Redux state. And at this point, the actions have not reached the reducers yet. Then we call next and send the action on down the pipeline where it will be processed by the reducers and Redux will be updated with a new version of the Redux state. Then we are able to use the store API again to call get state. And now we can get the copy of the state, the newest copy of the state after the reducers have processed this action. And then we're just going to go ahead and console log the old state and the new state. And this is just what Redux Logger does, except Redux Logger does some fancy diffing and produces a nice color-coded fancy output. So this is actually quite a powerful feature we've just seen. So just like recursive functions, how they build up on a call stack, the functions of the Redux pipeline also build up on a call stack. So the middleware has the opportunity to execute logic as the call stack is building up, but then again, execute logic as when the call stack is winding back down. And so this is how middleware can do work both before and after an action is processed by the reducer. All right, so let's look at a real world example. So this is the middleware code for redux-thunk, and it just happens to be incredibly simple. So if we walk through this body, we see that if the action type is an object, then we're just going to go ahead and forward that action down the pipeline. Otherwise, if the action is of type function, then this action is actually a thunk. And so this middleware is going to execute the thunk by passing it some goodies like dispatch, get state, maybe some extra arguments. And then this middleware simply returns here. So this is a different pattern than we've seen so far. When the action is a thunk, it doesn't forward the action down the pipeline. It forwards nothing down the pipeline. Actually, the pipeline execution simply ends here and then unwinds. All right, so this is not, I've already covered the slide. Why is this going backwards? Here we go. All right, let's move on to some action processing patterns. So middleware, as you've seen, is really flexible and powerful. Middleware can do anything it wants with a dispatched action. For example, it can swallow it, as we just saw with redux-thunk, or it could delay it, transform it, modify it, replace it, you name it. And just like reducers, middleware can selectively handle some actions and ignore others. So here's a nice graphic I found in the blogosphere. Thank you, Saad Hassan. And it shows a variety of action processing patterns. And I'm not going to speak to all of these patterns. I'll just speak to a couple. The first pattern is filter. And we actually did just see this with redux-thunk middleware, where it filters out actions that are thunks. We're going to use a couple of these in some upcoming examples. So I'll go over enrich. I actually usually call this enhance myself. But the idea here is that the middleware takes an action and then appends data to the payload. It could be static data, or it could be data from the Redux store. So you see here the action is looking like a bigger green circle because it has got more data on this action payload than when it came through. The one next to it is called normalize. I'm going to use this in upcoming examples too. And so I know normalize can be a loaded term, but here I interpret it to mean taking action data that is that are different shapes perhaps, and then converting them into a specific shape, into a normalized shape. All right, so let's talk about layered architecture. So I'm a little old school because I'm a little old, but I really like my layered architecture. I really like the concept of organizing my code into modules that have a purpose. And so I know where to implement specific types of logic. And, I grew up in desktop, working on desktop UIs, and we had classical MVC, MVP, and those kind of things are a little passe. But in reality, layers themselves, I think, are still a great idea. And layers are not limited to the old examples. You can create as many layers as you want, as many layers as you need for your app. And as I look for creative ways to use custom middleware, I see that it's actually really a good natural fit for creating layers in our layered architecture. So I'm going to go ahead and walk through an example. Let's say we want to build a collaborative text editor, much like Google Docs. It should be a web app hosted in the cloud, should allow multiple people to edit the document simultaneously, and everyone's edits should be shown in real time. And we're going to go ahead and support undo redo for all edits. So in this proposed solution, I'm going to have a typical web app layout where we have got a React Redux front end. The Redux store will be the source of truth, so it'll contain all the data needed by the React components to render. And we're going to have a centralized backend server that relays messages from one client to another via WebSockets. And WebSockets is great because not only can a client, make a request, get a response, but WebSockets allows the server to push messages to any of the clients at any time. So it's more of a duplex two-way communication channel compared to REST. So in addition to all that, we are going to convert edits from different sources, whether they're local edits, remote edits, undo redo edits, into a JSON object that represents a normalized edit. And this is going to allow us to have our middleware and reducers operate uniformly on the normalized edit, regardless of the edit source. So for example, if the edit is typing the letter A at the beginning of the document, that could be achieved by the user typing the letter A in the local text editor React component, or it could be generated by a remote user typing the letter A in their local web client, and then having that message get relayed, pass through the server through WebSockets back to us. So we see it as a remote edit. Or maybe it's a local user creating that edit just by hitting undo or redo on their local keyboard. So regardless of which type of edit it is, we want the reducers to be able to handle that edit in a uniform way, because regardless of how the edit got there, the React component that represents our text editor should show the edit. All right, and then finally, of course, we're going to implement this using a layered architecture of custom middleware. So for our custom middleware layers, I'm going to outline 4 here in this example. So the first middleware layer is called initialization, and it can be responsible for making the WebSocket requests to the server to gather all the data needed to initialize the app state when we first open the app. The remote edit middleware will be responsible for processing WebSocket messages from the server, which represent remote edits, and to normalize that into our normalized edit form. The local edit middleware can process actions, which are requests from the React components, and convert these local edit requests into the normalized edit we spoke about. And it can also go ahead and make the WebSocket call out to the server to persist local edits. Not only will the server persist those edits, but it will also relay those edits out to other remote clients. And the undo redo middleware is gonna determine the undo for a remote edit, for a normalized edit, and create the undo redo transaction that we need to store on the undo redo stack so we can achieve this edit later. All right, so let's walk through a couple of scenarios. So the first scenario is when we first open up the web app. In this case, perhaps our app component in component, when it mounts, will dispatch a initialize action. And oh, I should use my mouse. And this action gets picked up and processed by the initialization middleware, as we said. And the initialization middleware will make the WebSocket calls to the server, gather all the data we need, the initial state of the document as we open it, and enrich the initialize action payload with all the data needed, and then forwarding on the initialize action down the pipeline where it ends up at the reducer. And now the reducer can take all the data off that action payload, update its copy of Redux state, and the React components can reflect the initial state of the app. The next scenario is inserting text. So let's say the local user is typing in the text editor component in the web app. Oops. Oh, sorry. Here we go. The text editor component will dispatch an insert text action, with the text that the user has typed. And it's going to flow through the pipeline untouched by the init middleware, remote edit middleware, but it's going to get processed by the local edit middleware. And so the local edit middleware is going to take this request to insert text, and it's going to change it into the normalized edit form, and then call out to the server to inform them this edit has occurred. Then it's going to enhance the action with the normalized edit and send that down the pipeline, where it's going to get picked up by the undo redo middleware. So the undo redo middleware knows how to accept this normalized edit on the payload, and it's going to determine the correct undo edit that matches this current edit, and then package it up into an undo redo transaction to be prepared to persist on the Redux store for the undo redo stack. And so the action gets enhanced again, it's a little bigger, a little heavier, and it gets forwarded on to the reducers. And then the reducer that is responsible for the document model is going to get that normalized edit and update the document model, which will cause the text editor component to update and reflect the newest edit. And then the undo redo reducer is going to pick off that undo redo transaction that we appended onto the payload and add it onto the undo redo stack. And finally, the last flow I'll walk through is the remote edit flow. And so in this case, we get a WebSocket message from the server that says a remote edit has occurred, and we handle that with a callback that we've registered. And that callback is going to dispatch a remote edit action, appending to the action the remote edit itself. And then it's going to flow through the pipeline and get handled by the remote edit middleware. That is going to take this remote edit from the server and convert it into this normalized edit form we've spoken about, and then enhance the action payload with that normalized edit. And then the remote edit will flow through and get picked up by the undo redo middleware. And the undo redo middleware can create the undo for that normalized edit and the undo redo transaction, as we spoke about, enhance the action again, and then send that action on down to the reducer, where the same things happen. The reducer is able to pick off the normalized edit to update the document model so the current text editor can reflect this current edit. And of course, the undo redo stack gets updated as well. And I'm going to pause to note here that actually at Workday, we found that having undo, redo support for remote edits is actually pretty confusing. So we have changed to a model where local users can only undo their own local edits and not remote edits. But this is just an example. This is not actually my Workday product or anything. All right, so this is what it looks like when you put it all together. So what do you think? Are you taken by surprise? This is quite a novel Redux architecture, and you're not going to find an example like this in the blogosphere. This is a different approach from spreading logic out over components, action creators, customizable middleware, and large reducers. Using this approach, I reduce the amount of data and business logic in the React components because actions are dispatched containing minimal information. I avoid putting logic in action creators, so my action creators are simple and I don't have to worry or deal with thunks. I also minimize the amount of logic in reducers, keeping the scope of the reducers to updating state in an immutable fashion. Instead, I put most of my logic into layers of custom middleware, which enhance actions with additional information as they flow through the pipeline. So what are the benefits? Well, I like the idea of creating distinct modules with specific roles and responsibilities. This further achieves separation of concerns in the app. I can keep related code isolated and co-located. And I like having a clear structure for finding, updating, and adding code. And finally, the middleware boundaries, as there are, the middleware boundaries make mocking and unit testing easy, as there are clear interfaces for where data comes in and where data goes out, as we've already seen. All right, so that brings me to the end of my talk. Thank you so much for listening. And certainly I'm here for any Q&A that you might have.